Hi guys, welcome back to CalcFly videos. In this video, we're going to be talking about question 2 from 2018 AP Calculus Fair Response portion. Alright, in this problem, we're given a particle moving along the x-axis, and also we're given its velocity. Its velocity defined to be this way, that the position of the particle when t equals 0 is -5. So in the first problem, we need to evaluate the acceleration at t equals 3. So we know that acceleration is the instantaneous rate of change of velocity. Okay, so basically a of 3 is going to be equal to v prime of 3. So since this is a calculated permitted problem, if we use our calculator, this value is going to be equal to -2.118. That means the acceleration of the particle at time t equals 3 is -2.118. Alright, we've tackled the first problem. So let's move on to the second problem. Let's try to handle that. Alright, in this problem it says find the position of the particle at time t equals 3. Okay, so basically the position of the particle at time t equals 3 can be found by this expression. X of 3 is going to be equal to initial position plus from 0 to 3 v of t dt. So since this is an accumulation problem, we need to always establish the definite integral like this. So we know that x of 3, which is the initial position of the particle, is -5 plus 0 to 3 v of t dt. Again, if we use our calculator, the result that we're going to find will be -1.760. Alright, so that's the position of the particle when time t equals 3. Alright, so let's move on to part C. In part C it says evaluate integral from 0 to 3.5 v of dt and evaluate integral from 0 to 3.5 absolute value of v of t dt. So interpret the meaning of each integral. So basically this integral from 0 to 3.5 velocity dt is going to give us the displacement of the particle over the time interval Okay, and also this expression from 0 to 3.5 absolute value of v of t dt, it's going to give us the total distance traveled by this particle over this specific time interval. Alright, so let's calculate these two. Alright, so let me erase this part. So okay, so the first integral is going to be equal to if we use our calculator, because this is a calculated permitted problem, we're going to end up with this result, which is 2.844. Alright, and if we calculate this total distance traveled by the particle, and this is going to be equal to 3.737. And also we've explained the meaning of these two integral expressions. The first one is going to be displacement by the particle over that specific time interval. The second one will be the distance traveled, total distance traveled by the particle over this time interval. Alright, okay, let's move on to part D. So before I move on to part D, I need to clean up this board. Okay, so the part D is going to be equal to, okay, so let me use a different color. What does it say? It says the second particle moves along the x-axis with position. So basically this is the second particle with its position x of 2t. It's going to be equal to t squared minus t. Alright. And also this is the second particle. It says at what time t are the two particles moving with the same velocity. Okay, so if I want to figure out the answer of this problem, if I want to tackle this problem, first I need to figure out the velocity of the second particle. So the velocity of the second particle is going to be equal to if I take the derivative, so we get 2t minus 1. And we also know the first velocity, which is this function, 10 times sine of 0.4 t squared divided by t squared minus t plus 3. Okay, if I want to figure out the time when this two particles are moving with the same velocity, I need to set them both equal to each other. So basically 2t minus 1 has to be equal to 10 times, so let me read this part, so it's going to be equal to 10 times sine of 0.4 t squared divided by t squared minus t plus 3. So since this is calculator permitted problem, we can use our calculator. We can put this expression into our calculator and hit enter. We're going to end up with this answer. T is going to be equal to 1.574. Okay, so when we deal with free response problems, we always have to include 3 digits after the decimal point actually. So after the decimal point, we need to include 3 digits always. All right, so for this part D, we've got the derivative of the second particle, which is equal to 2t minus 1, and I set the two velocities equal to each other, and then we got this. All right, guys, thanks so much for watching my video, question 2, and don't forget to subscribe, like, share, and comment. Bye-bye.